This is a brief tutorial on solutions and concentration, including dilution. So, a solution is a mixture of two or more substances where one is dissolved in the other, and that's typically a homogeneous mixture. A solute is a substance that's dissolved or is present in the smaller amount. The solvent is a substance present in the larger amount or the one that does the dissolving. In aqueous solutions, the solvent is water. And concentration of a solution defines the amount of solute dissolved in the solvent. One common concentration unit is percent by mass. Percent mass is defined as the mass of the solute divided by the mass of the entire solution times 100%. Mathematically, the mass of the solute percentage will equal the mass of the solute divided by the mass of the solution times 100%, where the mass of the solution would be the mass of the solvent and any other solutes if there happen to be more than one. If there's only one solute, it'd be the mass of the solute plus the mass of the solvent. So let's say we have a 12% KOH solution. We know what volume of that contains 40 grams of KOH, where the density of that solution is 1.11 grams per milliliter. So if we start with our 40 grams of KOH, we can use the 12% as a conversion factor if we assume a 100 gram sample. So we divide by 12 grams of KOH and multiply on the numerator 100 grams of KOH solution. And therefore, we've used the percentage as a conversion factor by assuming a 100 gram sample. Next, we need to use the density. We can see grams of KOH solution cancel, so we divide by 1.1 grams of KOH solution, multiply by 1 milliliter of KOH solution. That gets us into volume, giving us 300 milliliters of KOH solution. So let's look at another example. Calculate the percent mass of a solution made by dissolving 25.2 grams of potassium bromide into 250 milliliters of water. Here we'll assume the density of water is 1, so the 250 milliliters is 250 grams. So the percent of potassium bromide will be the 25.2 grams of potassium bromide divided by 25.2 grams plus 250 grams. So we have to get the mass of the whole solution by adding those two together. Times 100% will give us 9.16% potassium bromide. Another common concentration unit is molarity, and it's actually the most commonly used concentration unit in general chemistry. And that's defined as the moles of solute per liter of solution. Mathematically, you see that down at the bottom. Molarity is moles of solute per liters of solution, or moles per liter. Or alternately, you could use millimoles per milliliter, but depending on the textbook, that may or may not be done. So let's calculate the molarity of a solution that contains 12.5 grams of sulfuric acid and 1.75 liters of total solution. We'll need the molar mass of sulfuric acid. So we're going to say 2 times 1.01 grams per mole plus 32.07 grams per mole for the sulfur plus 4 times 16 grams per mole for the oxygen, giving us a total of 98.09 grams per mole for the sulfuric acid. You can look at my moles video if you want to know about adding up molar mass in more detail. So if we got 12.5 grams of sulfuric acid, we're going to use our molar mass to get to moles. 98.09 grams of sulfuric acid, divide that into the 12.5 per 1 mole of sulfuric acid. So that gives us moles. And then we're just going to divide through by the liters of solution. So we got moles per liter. And so we got 0.0728 molar, where the molarity is the capital M. So let's look at Another example, we want to calculate the mass of cupric sulfate required to make 500 milliliters of a 0.100 molar aqueous solution. This is a little bit of the backwards problem as the one we worked before. So we're going to calculate the molar mass of the cupric sulfate, 63.54 grams per mole for the copper, plus 32.06 grams per mole for the sulfur, plus 4 times 16 grams per mole for the oxygen, giving us a total of 159.60 grams per mole for the cupric sulfate. So we're going to start by converting that 500 milliliters to 0.5000 liters, and we'll use the molarity, 0.100 moles of cupric sulfate per 1 liter to get ourselves into moles. And then we'll multiply by that molar mass we just calculated, 159.60 grams of cupric sulfate per 1 mole. Run that through our calculator and we get 7.98 grams of cupric sulfate needed to form 500 milliliters of a 0.1 molar aqueous solution. Dilution. To dilute a solution, we're going to add solvent to the concentrated solution to make the solution less concentrated. This is how we make a fountain drink from the syrup. And diluting the syrup with carbonated water will make the fountain drink. The number of moles of solute in both the solutions remain constant, however, because we're just adding more solvent. The amount of solute remains the same. The relationship is M1V1 equals M2V2, where M1 and M2 are the concentrations before and after the solution's been diluted, and V1 and V2 is the volume of the solution before and after it's been diluted. This equation is appropriate for dilutions but not for chemical reactions because there's no way to know whether the moles would be the same, and in many cases the moles aren't the same, depends on what the stoichiometric coefficients are. So let's look at an example. If we get 10 milliliters of 12 molar HCl, we add that to enough water to give us 100 milliliters of total solution. What is the concentration of the solution? So we're going to use our formula M1V1 equals M2V2. Solving for M2 because we want the final concentration, we got M1V1 over V2. Now let's plug everything in. We got 12 molar times 10 milliliters divided by 100 milliliters. Milliliters cancel, gives us 1.20 molar as the final concentration after we diluted. In this last example, we're going to change up the dilution a little bit. We want to know how much water must be added to 50 milliliters of a 6 molar solution of sodium hydroxide to dilute the concentration to 4 molar. In this case, I asked for how much water needs to be added. That's an important distinction to make. These problems are not necessarily difficult, but if you don't read them carefully, you'll miss it because some problems may say how much water needs to be added or how much water is added versus what is the volume of the total solution. You need to be careful to make that distinction. Regardless, you end up with the same formula, M1V1 equals M2V2. Since I'm asking you for a volume, we solve for V2, so V2 equals M1V1 over M2. But note, V2 is the total volume of the solution, and it's not the volume of water that was added. But regardless, let's plug in 6 molar times 50 milliliters divided by 4 molar. The molarities cancel. And we get 75 milliliters, which is the volume of the total solution after it's been diluted to yield the concentration of the 4 molar. Now, to get the volume of water, we're going to subtract the 75, which was the total solution, minus the 50 that we started with from the original solution, meaning that we would have 25 milliliters of water added to the solution to dilute it to 4 molar. This has been a brief tutorial on solutions, concentration, and dilution.